So, as you probably know, many large language models are distributed using files with this extension GGUF. They are very large files usually, and inside such files there are tensors. There are basically the weights of neural networks, the attention weights, the feed-forward weights, the token embedding weights. And this is the format used by the Llama C++ project and all the other projects that are based on llama.c++, providing less or more credit to llama.c++. So I built this library 2 years ago before returning to work to Redis, just as a personal fun project. And I didn't fail to mention llama C++, fortunately. And yeah, this is basically a serialization format, and this library implements the format in a more self-contained, clean way. So it's kind of also some kind of documentation of the format itself. For example, if you check this file, this C file here, you will see that there are all the quantizations explained, because the tensors normally now there are at this point large language models which are trained natively with less precision, so they are quantized during training, or they perform quantization aware training. There are multiple techniques that have the same goal. Other large language models are just quantized, that is, you do the training with floating point 32 bits, so 4 bytes per weight, per parameter, whatever you want to call it, and then you quantize, losing precision even if the training itself was not aware of that. But anyway, I built this library, and I wrote, using the library itself, some tool like that, GGUF tool show, and you pass a model in GGUF format, and you see the architecture, the context length, and then you can access the tokens vocabulary, and so forth. And also you can access the tensors, of course. Why after 2 years I'm here telling you this? Because recently I saw a few blog posts about inspecting, in some way, trying to understand the embeddings of large language models representing tokens. And usually this is done by squashing the dimension of the embeddings, which is a very large dimension, into two-dimensional vectors in order to display them. But when you reduce something like 2,000 components to 2 components, the reality is that you don't see much more than some clustering, but you lose most of the information. So to start, what are the embeddings in large language models? Well, basically we put text as input of a large language model, and what we got as output is a distribution of the next token, basically the probability of the next token, if you want to see it as a probability, or if you want to see the model as having some more semantic, you can think at it as how much the model is would like to continue the sentence using a given token, a given output token. But here we will not zoom into this fight about stochastic parrots or not. Who follows this YouTube channel anyway have some clue about what I think. But in general, let's call it the distribution of probabilities across the tokens. And then you have a sampler that decides what token to take. But the interesting thing here is that you have the inputs and you have to represent different words, which are actually tokens, which are actually words for very represented words in the input training, in the input set, and pieces of tokens in order to compose the other words that don't fit into the vocabulary. Normally, a large language model have a vocabulary of 200,000 tokens, 250,000 tokens. This is the soft spot among efficiency and good results for now. Actually, there are experiments trying to use larger vocabulary with very large language models, and this actually may produce better results, but in general, this is the vocabulary that you get right now. There are also systems that have smaller vocabularies, but I can anticipate that I put embeddings inside Redis of different models, and we can check what is the cardinality of Mistral Small. This uses not much tokens, total of 131,000, and then this is already in the range that I told you to be more optimal, when 3-coder is a bit smaller and so forth. So what are embeddings? Embeddings are word embedding. Okay, it's just a word and a token, in this case, so can be a fragment of words as well, is associated with floating point numbers that represent a point in a multidimensional space of meanings, and well, there is a difference between the embedding of a word in traditional word embedding systems like Word2Vec and what the LLM models, but we will arrive there. The interesting thing for now is that we have a word and we have an associated set of numbers, of floating point numbers, that represent the meaning of this word. However, what is, in my opinion, pretty interesting is how we arrived to have items in a neural network represented by a vector of floating point numbers. And I can show you here because it is extremely interesting. So imagine that you have a neural network where you have, for example, 3 input items, or maybe just 2 input items that can have 3 possibilities. So I have 2 inputs of symbols, of tokens, whatever you want, and imagine that I have 2 words in input, and I can have only 3 total words in my vocabulary. I can have cat, or dog, or foo. Okay, and in order to represent my inputs, very old systems used one encoding that was called one hot encoding. So in order to so I have a total of 6 input units in my neural network, and then imagine that I have an hidden layer with just 2 units. So each of these input units is connected here and is connected also here, and the same here. It is a fully connected network, this one, and like that. And then I have other 2, 1, few, and 3 output units in order to predict my next word or whatever you want. So this is cat, this is dog, and this is foo. And also this is cat, dog, foo, and cat, dog, foo, my 2 words. So in order to tell my model that if my sentence is dog, foo, I put 1 here because it's the second word, and 1 here because it's the third word, and these 2 will be 0 and 0 and 0 and 0. But if I do something like that, just a given set of weights will be activated, just the ones associated with 1. So I will activate this weight, and I will activate this weight here. And all the other weights will be 0. And also the problem is that here, if I have dog and dog, I will have separated set of weights, okay? So the researchers said, wait, but actually each position here will just map to a set of weights, to a vector basically. So why we don't use directly vectors, and also we share the same vector for the same word. So that's the initial idea. And this is how things started about embeddings. And one interesting thing is that word2vec, it's probably the most famous embedding vector space. It's trained with a very shallow network, whose task is to predict a masked word usually, and however, it doesn't really capture very high level concepts. So for example, let's go in Redis vector sets. I have word2vec here. Get me the similar words to cat. Cat, cats, dog, kitten, feline, beagle, puppy, pop, poop, pet, felines. Sorry for my terrible accent. Anyway, these are very related words because in the classification task, then we throw away the last layer that really outputs the what word will come next, and we just take the embedding because the network tried to compress in the hidden layer the meaning. But in large language models, we don't use word2vec. The embeddings of the model are also learned during the pre-training of the large language model. So the model will see a lot of tokens in input in the pre-training step, which is the computationally basically the largest, even if the new reinforcement learnings are not trivial, but you know, it's the bulk of the training. And when this happens, the LLM can train the embeddings associated with each token the best as it wants in order for the tokens to work well with the rest of the transformer network. One very important thing that many people don't know is that in the transformer, even if the attention is performed among the input tokens, however, it is a masked attention, so you compute the attention of the current sequence of a given word with all the previous words and not with the next words. But then after you performed the attention and you get as an output your embeddings already attentioned that talked with the other tokens, then the transformer block, the GPT block, will take each word embedding singularly, okay, and will process it. So it's not, the transformer is not a neural network that will see all the text at once. There is the attention, then we pass each embedding in each in the first, for example, transformer block singularly, and then we do the attention again with a different set of weights, and then we perform this process again and again, and then we predict the next word, and we take the prediction only of the next token, and this is our logics, this is our probability of the next token. So basically, in a large transformer, things are a bit different. So how did I inserted my LLM embeddings inside Redis? I wrote a very trivial program, m2 Redis. Basically, I use my own library, GGUF library and Redis in order to insert stuff into Redis. And what I do here is to in the first step I read the vocabulary of tokens, and I create basically an array of tokens, and this is very simple. And then tokens of J is the token at position J. And then this is the interesting part. For each token that is associated to a set of weights, I create this command line for Redis here, vuadd, which is the command that adds a new vector to a vector set. Vector set is the Redis data type to manipulate vectors and then to perform vector similarity. So I do vadd, my key name, fp32 means that I'm using the vector in a floating point format, just a binary blob with each 4 bytes being a vector. And then my element, which is the string associated to a vector. So this is really perfect in order to model embedding tokens, since they are just strings associated to vectors. Yeah, see here fp32 token embed dimension times size of float. So yeah, it's pretty simple. And if I do this, let me see. Okay, I already added this, but I want to show you the process. So basically I load the vocabulary, and then I start to add my tokens to my key Mistral small. And then what happens if I monitor my Redis? I will see a lot of blobs. Let's see if I can see where a command starts. I can't, because it's a total mess of things. Okay, but well. And okay, I will stop here because I already have everything. Okay, so let's check how different, in order for us to figure how a large language model models its embedding during training, to make them as useful as possible in order to understand the meaning of a sentence, and also in order to make as effective as possible to process the multi-head self-attention and later make these tokens useful. Oh, just one thing about this. GPT-2 transformers blocks. Okay, so modern transformers are have multiple blocks. This is one block, okay? But once you basically pass, you have all your embeddings, okay? You pass the first transformer block, then you have as output, as embeddings, as tokens, as you put as inputs. But at the second layer already, at the second transformer block input, the tokens will no longer be the tokens of the vocabulary. They are already processed. They mean something more abstract. And at each block, the embeddings will no longer be the embeddings of the vocabulary, will be more and more abstract. So this is very important. The embeddings that we are checking here are only for the input of the first block of the transformer, and then the transformer processes things that are more ideal at each step, more elaborated. They talked more and more, and were distilled into something else that captures the meaning and not just the single word. So, for example, in Word2Vec, if we check Apple, what is similar to Apple for a very shallow network that needs to understand basic relationships among words? Well, apple is similar to apples, to pear, to fruit, to berry, and so forth. Instead, if I check with Mistral small, sorry if I from time to time I block and I am a bit confused, but at the same time there is a dog that I hope it's not picked by the MacBook microphone. My mother is talking and there are multiple sources. It's the last days that I am here in my hometown in Campobello di Licata, and it's very complicated to do things. Okay, let's see what means apple for to which what we don't really know what it means for the LLM, but I mean what similar tokens we find inside the vocabulary. Count 50. Okay. For example, he knows that apple is also some kind of method which is related to WebKit, which is a fruit, which is Azure, the color, or the cloud platform. And also it is similar in the sound to apply and also to orange and Casso, Apple and Casso, I don't know. Plain, Amazon, Google. So you see, it's very different the way it works. It's related to Windows, for example, and symbol. Apple is symbol devices, and Google and kernel. You know, it's a completely different story. We can not really know exactly the components, how they are designed, this vector space, in order to make it especially good in order to perform the self-attention and then to be preprocessed by the attention by the transformer blocks later. But we can already, just by cosine similarity among the tokens, we can see that something different is going here. For example, what is Python for Mistral? You see, malloc, perl, it's mostly a concept about programming, more than like an animal. If I do the same with Word2Vec, yeah, here actually it's the same. Like, let's check. Okay, here the difference it's huge based on the fact it is a capital P or not, which is interesting. Let's see if I put here no, for the large language model, this kind of relationships are high level anyway, whatever is the case. of the first P. So that's, I believe, really interesting. Now, for example, I want to explore while. While for a large, for a model like Mistral Small already has means things that are about the human language and things that are a lot about programming. For example, while is related to when, but is also for, which is a programming thing, and if, which, until it's in this semantic space, whose, quanto, strange, because in Italian it will be quando. I don't know where this is, how this relation. It's not always. Mentre, yes, it is while in Italian. Mistral Small is a very multi-language model. I believe it may have more percentage of Italian compared to the other large language models. So we can see here that there is also some related words which are in other languages. You may wonder what this is, and I will show you. Python. Sorry. The code, sorry. Exactly. It's this special character, which means that basically there was a space. This is depends on the exact tokenization technique used, but usually this means basically that there was a space before the word. So just ignore this, and en cuanto. This is in Spanish, maybe, I don't know. However, I put different large language models embeddings here. So let's see the same thing, for example, in GPT OSS 120 billion. While, also, you see, just the tokenizer. That's interesting. Maybe there is... while also is available as a token capitalized, but it's also in this fashion. Though, whilst, although, if with also, you know, the line ending character, and aunque, and quando. Yeah, it's a mix of different meanings. Oh, interesting. Let's check Redis. Redis is extremely common in large language models, tokens. There are much more fundamental words that are missing sometimes, and Redis is here because probably it's too much exposed in different parts of the code. Redis is similar to Reddit, which is interesting because they don't share much semantically. This is a social news site. Redis is a system, but maybe Reddit sometimes is in Redis is very mentioned in Reddit, in programming communities. Also, maybe in the engineering post of Reddit, sometimes Redis is mentioned. So this is a very high level association. Very interesting. Red, Mongo, of course, recycler. I don't know what it means. Elasticsearch, Firebase, some are obvious, other are less obvious. Router, Twitter, DNS. Okay, DNS for the configuration. This may be related to things that you see in cloud environments, Redis routing for high availability or something like that. Jedis, many Postgre. Let's go. Wow, more matches. Sudoku, Railroad, sparse Spotify, cookies. You see so many, because you know, when we do vector similarity among two things inside our vector space, maybe these certain vectors have a very strong association in certain components and a very weak association in other components. So we see, of course, a mix about many things here. Now let's check Quencoder 3. This is interesting because this is a specialized model that during the pre-training saw a lot more code than English text and other text of other languages. I guess this also saw a great deal of Chinese text as well. Vusim, Quencoder 3, Apple, pineapple, count 50, app, yeah, the Apple iPhone app has a lot of relationship. Alice, Cocoa, this is maybe for Cocoa, because yeah, imagine how many Swift Apple iPhone application projects that was seen by this thing after they do the scraping of GitHub and stuff like that. Cocoa here, tomato. Ah, okay. HTML and so forth. Let's check Redis here if it exists. And Redis is also associated with the other things. One thing that is quite obvious is that static word embeddings, these are totally trash. They are not good. Better to use word2vec. Also, I have here fast text. Vsim fast text. There is no Redis here in this set. Apple. Okay, these are much more solid. MySQL. There are no technological terms. Python. Nah. Python, Monty, per JavaScript. This is much better basically. Oh, this is because these were added just in low case. Basic visual. Yeah, basically you see don't have a lot of garbage here. It's much better in many ways for static embeddings to use just word2vec or other static embedding things. Okay, just as a last test, let's see. Vusim, Italy, Brazil, Spain, count 100. Europe, Liverpool, Colorado, Canada. Okay, this was Quencoder. Let's check Mistral small. Yeah, this is there is not much odd things about not many Mendel association between Italy and the other things. Well, it's the name of a country, it makes sense to be like that. But let's check GPT OSS. Country. Oh, this is it's a country. It's America, which is also a country. And yeah, here the tokenization thing is a bit more represented. India, Spain, Okay, yeah, this is more obvious. Anyway, if you want to play with this stuff, you just need github.com gguf tools. Okay, and inside utils I put this stuff here. You just download any Redis version 8 or greater and compile it, and then you compile this script. And if you have your gguf file, where it is, I don't know anymore. Okay, here you just use this utility. You tell it the gguf file, the name of the key, and then your Redis host and port, only if they are not the default. Thank you for listening. Bye.